Hello, and welcome to the first half of Project 3.2, also known as the CHOMP, for Cheap, Homemade, Understandable Minimal Processor. Here we can see the first half of the clock circuit. This is the potentiometer that modifies the A-stable circuit as seen by the green LED. Next to it is the monostable circuit, which is controlled by a button as a button debouncer. Then, next to it is the bistable. We'll see that in approximately 1 second. Here we can see the clock circuitry. When the switch is set to the right, the logic circuitry interprets it as the monostable mode. However, when it's set to the left, it takes the A-stable output. Originally, this circuit was designed to be a combination logic circuit of several chips. I used only NAND gates to restrict it to only 2 chips necessary. This is the counter circuit. Its main component is the 74LS161 4-bit counter chip. The main purpose of this circuit is to function as the program counter, and increment by 1 every time the clock is pulsed, or have a preset load. In the bottom here, you can tell that we have 0, 0, 0, 1 as a preset load. Now, if C and F go high, the NAND output of this will run into the active low of this 161, which will of course load that bit. Now, that of course makes sense. We definitely need that in the circuit. Now there's one other feature that we probably need in the circuit. That is the clear. If clear is pushed, it wipes all the bits from the output. It sets it back to 0. There's one thing I'd like to draw your attention to. This LED right here. You saw it just flashed. Well, that is, in fact, the ripple carry out. If you wanted to connect 2 of these together and end up with a 8-bit counter, that's what you'd have to connect the clock pin of the other chip to. These go to the first 4 addresses of the EEPROM chip, which you will see shortly. This is the program EEPROM. This can store multiple different versions of code. I'm pointing to the wire here because if I set that to low, I can select Feinberg's code. The code that's running here is my code. The goal of this code is to calculate the Fibonacci sequence. First, I load B, store it, load A, add the 2 together, set A equal to B equal to F, and then repeat the process over and over again. Of course, there are other steps like using the address bus, but currently I'm just displaying my code running on this display. Here we can see how I've segmented the code. On the left 3 bits, that's the instruction of the opcode. In the middle is the constant versus memory, and the 4 bits on the right are the constant. Now, let's go see what Feinberg's code looks like. Here we can see Feinberg's code running on the same chip. Now, the bit has been set to low, so it's running the first program that's been flashed onto this. Here we can see Feinberg's code running. Then we see all the bits high. Thank you very much for watching. I'll see you all in part 2, when the entire chump is working. Farewell.